So we'll start off with a keynote by Lokesh Babu Pundrika, AE Director, System Verification Group from Cadence Design System. It is titled Verification, a critical enabler for the trillion-dollar chip design industry. An introduction to Lokesh. Lokesh Babu is currently working with Cadence Design System Bangalore Center as AE Director for the System Verification Group. He has been associated with Cadence for the last 15 years and has spent a total of 22 years in the ASIC and EDA industry. He has predominantly worked on pre- and post-silicon verification and enabled successful SoC verification for major customers in India. He was instrumental in pioneering assertion-based verification methodology and automotive safety verification. Lokesh has authored several articles on assertion-based verification, reusable stimulus, coverage convergence, and formal verification techniques and presented them at various prestigious conferences. He holds a master's in microelectronics from BITS and a bachelor's in electronics and communication from Osmania. Lokesh is also an ISO 26262 certified engineer for functional safety. Please join me in welcoming Lokesh Babu.
We have interesting video to play for you guys. Hello everyone, good afternoon. Hope you had nice lunch. Did you like the lunch? Yeah, after having nice lunch, it's hard to resist from the sleep, right, or awake. So let me try my best to keep you guys awake with some interesting information from my presentation, right? So once again, welcome you all to DVCon India. Good to see you, or good to meet you guys face to face after a COVID break. And it's been almost 3 years that we not met face to face and interacted, right? So this is a good forum for you guys to interact and exchange information, right? So let me start with recent experience that I had with my friends and relatives. Last 6 to 8 months back, I think I've been reached out by my relatives or friends saying that, Lokesh, I think I'm trying to buy a car, I'm trying to buy a dishwasher, microwave, but everybody says that there's a silicon shortage. What is that? What is that silicon? I don't understand why a silicon shortage is stopping a car delivery or a microwave delivery or dishwasher, right? So in the past, actually, I tried to explain people saying that, guys, what I do at Cadence and how my work is really impacting your day-to-day life, but nobody was bothered, right? But now, interestingly, everybody is coming to me saying that, yeah, Lokesh, tell me, I want to understand what is silicon. I know that you are working in the semiconductor industry. Can you educate us, right? So keeping fun aside, the semiconductor shortage or silicon shortage is actually teaching a lot of people that how semiconductor is being getting used across the different applications, right? And when I've been reading some of the articles, right? So I think silicon is getting used in many applications which not even imagined earlier, right? So in the recent Semicon India event, which I attended, PM Modi ji gave the keynote, right? In the keynote, he clearly mentioned that India alone will start consuming close to 80 billion equivalent semiconductor chips by end of 2026, a huge growth. And it's expected to grow to $110 billion by end of 2030. It's a huge market within India. Imagine whole world, what is the growth going to happen, right? So market study says that we might touch close to $1 trillion by end of 5 years, by 2027. So huge opportunity for all of us, right? Again, opportunities are coming with a lot of responsibility, right? So as we know, verification, as a verification engineers, we know that verification is a critical process in the chip design, right? You take it hardware verification, software verification, right? Or mixed signal, analog, RF verification, everything plays a very critical role. And I can say that, probably say that verification can actually decide the fate of your chip. Do you agree with me? Right? So if you don't do your design verification properly, I don't think your chip can be useful for any of your customers, right? It's very important. So today in my keynote, I'm going to talk about what are the different challenges being posed by a growth in the semiconductor industry and how we at Cadence think these challenges and trying to solve some of these challenges using our innovative solutions, right? So let's look at what I have today for you. Hopefully I keep you guys entertained throughout my presentation. So as I mentioned, in next 4 to 5 years, the whole semiconductor industry is going to touch close to $1 trillion business, right? And if you look back, what are the major drivers or generation events that are happening to grow this semiconductor demand, right? As I mentioned here, in automotive, industrial, 5G, deep learning, cloud, I think all of them are contributing to the growth. In the past, if you look back, maybe 20, 30 years back, the demand or growth of semiconductor used to be very cyclic, right? In late 80s and 90s, the demand was primarily because of PC innovation, right? A lot of people want to use a PC laptop, then there's a lot of demand for chip design or a lot of demand for silicon. But it started dying down, but suddenly there's a big boom around the mobile, right? In early 20s, a lot of demand on the mobile phone, then it started pulling a lot more silicon design or demand for semiconductor, right? But I think we thought maybe late 20s, mobile is pretty much saturated. There may be not much demand for semiconductor. But interestingly, a lot of these drivers like automotive, industrial, 5G, cloud, everything started pulling a lot more demand for silicon, right? So this silicon demand actually creating a lot more opportunity for us to enable best technologies and provide a better solution for our end customers, right? So today I'm going to talk about some of these key drivers, how they are impacting the demand and what is the challenge they're posing to us, right? So if you look back, along with these generation drivers, I see there are two more factors or two more reasons why there's a lot of demand for silicon, right? So you might have seen a lot of system companies like Google, Facebook, or Amazon, everybody started doing their own chips. It was not there earlier, right? So this is also putting a lot more demand for silicon growth. And the second reason, which is major reason, is the data. So now data is everywhere. Every device which we are using today is generating a lot of data, right? So without data, I don't think any device is working, right? So a lot of data is coming. So now a lot of space, scope for innovation in the data space. So that also putting a lot more demand for silicon growth, right? Keeping in all this mind, a lot more demand for silicon growth, which also brings that a lot of innovation needed in the silicon design, right? So I'll take it forward from here to give you some insights of some of these generation areas or drivers and how they're challenging us in terms of design and how they're challenging in terms of verification to us. The mobile, smartphone, or wireless connectivity continue to be a demanding growth for semiconductor, right? I mean, roughly in the market says that 30 to 40% of market growth is primarily happening because of mobile, right? So here I want to share some interesting fact. Again, I would like to take some data from DVCon India that happened recently. So Modi mentioned that the digital payment boom that happened in last 2-3 years in India, right? We never seen that. We never expected that, right? So data says that out of 3 transactions, the 2 transactions are done by digital payment. So that boom happened. What is the motivation behind? What is the enabler for behind that, right? So mobile, smartphones. Everybody now has smartphones or laptop or tabs or mobile phones, right? So huge growth enabled by smartphones. So from where the smartphones are getting designed? Us, right? So huge demand, and I'm sure there are many applications, gaming applications or any other shopping or entertainment application. They're going to drive a lot more mobile smartphone devices, right? So I expect to grow a lot more in the coming years. And as for data, I see we might supply close to 1.5 billion smartphones which are enabled to 5G. So huge, huge demand for that, right? So everybody's preparing, right? And we're expecting that close to $300 billion market OEMs going to make it out of this 5G phones. The huge 300 billion is huge, right? Out of that, I think all the people like chip designers or chip design companies can make around close to 120 to 150 billion dollars. It's a huge market opportunity for us to grow and enable and grab it. Yeah, right. So again, 5G, huge growth here. 5G is coming with a lot more challenges. Again, a lot more data is getting generated by all the 5G devices. So we need to understand how do we take this data, step forward and take right decisions. So I said, every device now is getting enabled with the 5G. So it means that every device can generate a data. Either you take a washing machine, you take a fridge, TV, everybody is going to generate a data, right? So, but there are some applications, you cannot wait for the decision to be made on the data, right? For example, take a automotive or a medical, and automotive, you are driving a car on the road, you suddenly saw an animal. So you have to take a decision whether to apply a brake to proceed. So you cannot send the data to server and wait for a decision to come from the server to take a move forward, right? So this is too late, right? You might lose a life or you might lose a financial things, right? So but now the decision need to be made on the device, which is an edge device, right? So all the computing is moved towards the edge. So it means that your device which is designed need to be analyze data much more faster, much more quicker, and take a decision on the spot so that it can be a right decision, correct decision for the user who are using it, right? So it's huge compute getting moved to the edge. Again, the device, what you could designing for edge, need to have a lot more data storage, a lot more processing power to enable this data analysis, right? So as you can see here, in the year 2027, we might be generating close to 1,500 zillion data which is huge data. So again, data is a space where a lot of innovation can happen, right? I see a lot of startups now, they're trying to come with some smart devices, smart analysis devices, either wearables or mobiles, right? They want to take the data and take advantage of it to help the end users, right? I've seen a lot of life insurance companies are trying to tie with the medical companies to take the health records and take the right decisions for the insurance, right? So a lot of innovations happening with the data, right? So again here, when there is a data, you need to have a lot of strong processing power CPUs, right? So I've seen, I think some of my friends are started their own startups to build some AI chip processors, right? So I expect close to 45 to 50 billion market share of only AI processor, which is a huge demand again. So it's huge complexity for us to analyze the data and take the right decisions, right? So challenges and growth is expected close to 14 to 15% in the data centers semiconductors, which is again a good growth for us to in next 5 years to address and make sure that our designs are meeting the expectations here. This is another interesting dimension, right? I think as you know, as you might have read about metaverse. So we all feel that next generation is all about metaverse, right? It might happen that maybe 3 years down the line, the whole conference, what you are having here physically might happen in a virtual world without losing the physical connect or interaction, right? So there's a lot of developments happening in the metaverse. And they're expecting that there's close to $800 billion worth of metaverse market will be there by end of 2027. It's a huge market. Again, anybody who want to participate in the metaverse, they need to have a device enabled, right? So like it can be VR, VI, smartphones to enable this metaverse, to participate in the metaverse, right? Either to have a shopping experience, whether you have a medical experience or talk to your friends or interact with or attend a concert which is happening somewhere in the world, but you still can attend from live from here, right? So everything can be possible only when you have this kind of devices within your hand. Again, these devices are designed by us, right? So there's a lot of demand for silicon for this kind of devices, right? So growth is expected here. As you can see here, the expected growth of around VR headset is around close to $60 million. It's a huge growth in this space, and I know a lot of my friends are working this kind of devices developments, and opportunities a lot, plenty of opportunities here, right? So you pick mobile, you pick AR, VR, or you pick edge. As I said, there are a lot of data coming in, a lot of processing is required, a lot of analysis is required. So it means that you need a lot of compute power on the chip. Whatever you're doing earlier may not be sufficient to make play with the data, right? So as you can see here, this is a typical representative of a next generation SOC, where you might see a lot more compute domains. You might have a compute domains maybe more than 500, 600 cores running on the same CPU. right? Same chip, which needs a lot of data processing, decision making. Similarly, you might need a lot of high-speed interface like USB 4, PCI Gen 6 to have a lot more bandwidth and lot more data connected to the devices, right? So a lot of innovation going to happen in the design space, right? Whether you name it, for example, if you are designing for a safe automotive and medical, you need safety and security is very important, right? Again, that's going to add a lot more complexity for the design, right? So keeping all together, right? So yeah, we're talking about increase in design complexity for addressing some of these needs, right? How is that going to impact the verification? That is all we want to understand today, right? So let's look at some of the data what I have. So on the left-hand side, you can see this is the data published by IBS marketing system, right? So we understand that making a chip is not an easy task. It's a $1 million investment that we're going to make, right? So, but study says that out of 100%, 65% been spent only on doing this verification, right? Since morning, we've been understanding about different aspects of verification. That is a very expensive area. Again, somebody trying to optimize expenses or cut down ROI, right? So this is an area where you really need to double click and understand how to optimize it, right? On the right hand side, I picked up data presented by ARM and NVIDIA in their different conferences. The first chart shows that this is CPU verification times been spent by ARM in there, right? So according to them, they're spending 10 trillion cycles to verify CPU alone. It's a huge data. If you look at it, if you compare, if you add it to the number of months, it's close to 12 to 13 months and close to 40 missions or 40 CPUs. It's a huge amount of time that's been spent on CPU verification. Similarly, to verify GPU at NVIDIA, even both on the emulation side and prototyping side, they're spending close to 1,000 trillion cycles, which is a huge data, which is equivalent to 18 months to 2 years time being spent, right? With the different configurations of cycles and missions, right? So it's a huge amount of data time been spent by DV team, right? So a lot of scope for us to innovate and optimize this space so that you can cut down your expenses and get the value out of it, right? So now the next set of slides I'm going to talk about at Cadence, how do you think this as a challenge? How do you look at this as a different challenge, right? And what are the applications, what are the solutions that we have to offer for you guys to cut down your verification time drastically so that you can wisely spend your expenses on the design. So as I mentioned, in the whole verification, the whole design cycle, we've been spending good amount of expenses or dollars on the verification, right? But as we move towards the new nodes or new technology nodes, like 3 nanometer, 6 nanometer, right? The amount of software content on the chips also growing high, right? So now putting together both software and hardware verification, there's a big challenge. Again, big amount of investments are going towards that. So this is another area where we can look at where to optimize it, right? And we all know as a verification engineer, later you find a bug in the design process, the more the amount of dollars that you need to spend, right? So we need to find bugs as much early possible in the RTL stage so that amount of expenses that you're going to pay for fixing the bug later will be cut down, right? So keeping this in mind, I feel that verification is all about mind game, right? So at Cadence, the way we define ROI of verification is how many bugs that you can solve per dollar per day, right? As a verification lead, as a verification in charge, you need to start thinking in this direction, ROI direction. Not about I'm going to run this XYZ tool, I'm going to run this coverage. No, you need to look at what is the ROI I'm going to bring to my company, what is the ROI that I'm going to bring to my team, right? So this is what we call as a throughput, verification throughput at Cadence. Means how many bugs I'm going to solve or fix per dollar per day. And that's what I defines my efficiency of verification. So once again, when I say verification throughput, it's not just about running a simulation alone. A lot more beyond the simulation, right? So you have multiple platforms, simulation, formal, emulation, prototyping. So efficiency across all the engines, not just only one engine. It's not enough that you could just run a simulation fast and you're done verification. No, you will be running the simulation, you will be running the prototyping, you will be doing a formal verification. So you need to look at the efficiency across these platforms. Not only the engines, you also need to look at how efficient you are picking up your platforms, either your LSF, grid. You need to make sure that right resource has been optimized for your regression, right? At the same time, the coverage. You have a coverage coming from the multiple engines. How do you optimize? How do you merge the coverage across so that you can take a benefit of it, right? The most important is the debug. I've seen today, every tool has its own debug. A lot of learning happens from the user. A lot of effort goes in debugging one platform to the other platform, right? So you need to unify the verification across the platform so that you can quick to debug, quick to fix it, so that overall efficiency will grow, right? So at Cadence, we think that, okay, you need to have proper verification methodology, start with the right planning, and have right a platform to execute, right? Get the coverage collected across the platforms, and have right methodology to track your number of bugs been caught per day, per dollar, what you're spending it, right? So this is what we define as a verification efficiency or throughput at Cadence. And let's look at what is that we have in our portfolio to address or fulfill these needs. So as you can see here, the platforms like virtual, formal, simulation, emulation, prototyping, they are industry-proven technologies, been there for quite some time. We have a lot of customers who have been using it very efficiently in their verification cycle, right? So Jasper is an industry formal, #1 formal technology. If you name top 10 semiconductor customers, they've been using this Jasper as a primary formal technology, right? So it's been proven. And we have Xcelium, this is third generation simulator, parallel simulator. Post NC and Incisive, this is Xcelium, is third generation. It has both single core, multi-core capabilities for you to run simulation much more faster. And our dynamic D, which is Palladium Protium, which is a #1 emulation prototyping technology in the market, right? Again, we have announced recently revision 2, which is a much more capable, much more faster in terms of performance, right? So, is that engines are enough? No. I think on top of the engines, we need to have smart debug, smart applications that can catch up more bugs for us, right? So we have Fabric on the top, as you can see here, the tools like Indago, VIP, System VIP, right? So Indago is our new platform for debug across the different platforms. Either you take the simulation, formal, emulation, or prototyping, you can have unified debug in terms of catching a bug, right? And System VIP is a pretty brand new technology being adopted by many of our customers in terms of system verification to catch system performance issues at the Fabric level or LPDDR level, PCI level, right? It's been adopted by many of our customers. And Perspec, which is a portable stimulus standard technology, and I feel that I'm proud to say this is the first technology to support PSS in the market. And it's been adopted by many of our customers happily and trying to cut down their overall verification throughput with the reusability across the IP to SOC and reusability across the simulation to emulation and prototyping, right? So they're going to bring a lot more value for productivity, a lot more beneficial for you to bring your verification closer quickly, right? So today I'm going to touch a little specifically on the new capabilities that we announced recently, last 6 to 8 months, in terms of what we have offer in the ML space, what we have offer in the dynamic geo space. So before that, this is a new product that we announced called Helium. So we have seen that in the market, a lot of scope for having virtual solution, right? So people have been using the existing solution, but they're finding a lot of challenges in terms of getting complete verification done using virtual solutions which are available, right? So Helium is a technology which we announced a year back, and we've been successfully enabling to multiple customers who find a lot of value out of this technology, right? So we have seen RTL verification, we have seen timing, GLS, but I think people do want to have more sophisticated solution for system C verifications or high-level synthesis verification, right? So Helium can offer a platform that can help you to quickly assemble all your IPs, system C IPs or C++ IPs, or whether you take it from your in-house or whether you can take the library what we provide here, right? So library comes with a lot of well-defined, predefined libraries that you can be plug and play, right? Also, this platform will help you to do both pure virtual or a hybrid. Hybrid means you can have some portions as a RTL, some portion as a system C, right? That way you can use platforms like both simulation and emulation to get a better performance out of it. And unified debug, this is very important, right? Whether you move from system C to RTL, right? You need to have similar feature to debug, source code debug, waveform debug, right? So it provides an equivalent debug for you to move quickly from RTL to C or C to RTL, right? So this brings a lot more productivity for you, throughput enable for you to complete your verification of very high level languages. The formal is a very interesting topic. I think, 2 years, 3 years back when we had these conferences, right, DVCon, I think number of papers around the formal was roughly maybe in a single digit always, right? This year we have seen close to 25 to 30 papers being submitted by formal. It shows the growth of formal adoption in the India market and worldwide as well, right? So formal continue to grow here. Most of the growth, if you look at steady, I think most of the growth is coming from the processor industry. A lot of processor companies have started adopting formal as one of the primary reason for the verification, from a primary goal for verification, right? So as for the market, I think we are expecting almost 15% growth on year on the formal adoption, right? So I see Jasper adoption going very strongly across the forums. And today I'm going to talk about the new features which are enabled in the Jasper, which is primarily driven by ML technology. I believe that formal and ML can go together much more stronger than any other technology. They can understand each other and can help you to find your speed parts much more quicker, much more faster, right? So typically what happens, you might have heard that, yeah, if I want to run formal, I need an expert. That is a typical saying, right? But I think we're trying to address that expert problem using ML techniques, right? ML technique can learn from your design, your setup or environment and try to take those learnings and replay it either in the regression mode or debug mode to get you the results much more quicker and faster, right? It means that you're trying to minimize the dependency on the expert who can help you to tweak your engine, tweak your constraints to get that results out, right? So proof mastering, which is a newly available feature, I think a couple of our early customers have started using it, finding a lot of value out of it. In fact, they reported saying that, yeah, with using these techniques, we are able to cut down our verification time by 10x or 10 to 12x, right? Huge growth, huge demand in terms of how it can help you to enable the faster turnaround time for formal verification, right? And I think most of you guys know about Deep Chip. There's a good article been published in the Deep Chip about how Jasper ML is helping them to cut down their verification. It's again, we're not talking, it's about end user is talking about their benefits, right? So I do recommend you guys to go and visit and read article. So this is a technology real, which is existing and people are using it. So another interesting area that we've understood from the market, from the user, that so data path verification. So we have seen very well established technology like Jasper for data control path verification. People have been using for quite some time, but there's a gap in the data path verification. Market is, the customers, like a lot of people coming back to, guys, so we really need some technology that can address this space, right? So, but this is not easy problem to solve it, right? You need to take a system C, C++, or system C RTL plus RTL, make sure that you verify them whether they are equivalent or not, and ensure that if there's a mismatch, you should be able to enable the AG debug, right? So you need to have capabilities to have better compile on the C++ and library support, right? Similarly, we have sophisticated engines or algorithms to take your C code and do the equivalent check with RTL, right? And also you need to have, as I said, the debug is going to be much more challenging in this space because you have to bring both C code RTL together to debug, right? So there are challenges, but I think this is the area that we invested good amount of time, and I think R&D come with a technology called Jasper C2 RTL, right? Which is announced some time back, and we have a handful of customers are happily using it, and when they came to us and, guys, we are seeing close to 100x gain on top of the solution that we had earlier, right? So it's going to help us in conversing and deciding whether my RTL is really matching with my system C code that you have written, right? And they do have, as I said, Jasper comes with this unified debug. Been very famous for the debug. For the people who are using Jasper, they really like the visualize here, right? So visualize has been enhanced to support your C and RTL equivalent check debug. It means that you can bring both C and RTL together and check what is the difference in the mismatches, right? So that helps you to, in terms of debug productivity. So as I said, ML is being major element that we are trying to bring back to the user, or bring to the user in order to enable the more throughput, more turnaround time in terms of meeting your expectations, right? So as I said, this is our third generation simulator, parallel simulator. It has both single core, multi-core capabilities. Recently we announced ML capability. So our primary focus here with ML is how can I cut down my regression throughput? So today, let's say you have 50,000 test cases and your regression may be taking a week long. Assume that you are hitting maybe 75% coverage. So now the question is, keeping this 75% coverage, can I cut down my verification time from 1 week to 2 days? Right? That is the primary goal for this ML technique what we have. So we have customers adopted this technology very successfully. In fact, in some of our Cadence events, they presented the success stories and the value they have seen, right? So as you can see here, on the right hand side, we have 3 designs taken as a sample, right? So as you can see here, the gain they've seen in the range of 3x to 4.5x, which is basically cutting down number of test cases that you really need to run to hit the same coverage, right? Without compromising the coverage. We are able to sustain the same coverage of 99% without dropping, but we are able to bring the whole the regression time by 3 to 5x reduction. So this is very successfully adopted by many of our customers. Again, is available technology. Anybody can go and try this today with Xcelium who are using it. And we are definitely working many more areas using ML around Xcelium to optimize the coverage and improve the coverage or get the coverage numbers much more faster than what you're doing today. So we'll talk about that in the next events. So last one, I think the dynamic DO, which is again, the name says that there are two friends that work together to enable you the better throughput, right? Somebody who want to move from Palladium to emulation, right? It's just a matter of week that you can bring the design, right? But today, traditional method says that if you want to bring any design on the FPGA platform, you have to plan a month time. Otherwise, you're not going to meet your expectation, right? But when you're using Palladium, moving to any prototyping solution like Protium here, it's just a matter of week, right? So we announced next generation dynamic DO, which is 2.0, which basically giving you 2x capacity, more capacity than previous generation, and 1.5x more performance on the previous generation, which is G1X1, right? And some of our customers report that they're able to compile the design, which is 10 billion design gate size in less than 10 hours. It's a huge gain that anybody can get out of this G2, right? So compiling in 10 hours, 10 billion is a huge gain in terms of throughput and turnaround time, right? So along with that, I think in G2 we are enabled much more deeper debug capabilities or trigger capability, which enable you to have faster turnaround time for debug, right? So when it comes to Protium here, Protium again, they want to bring much more faster performance over the Palladium platform, definitely the FPGA-based platform, and we are promising that you can get up to 3 to 5x better, more performance on top of Palladium, which is like if you're getting 1 megahertz on emulation side, you might get up to 5 to 6 megahertz, which is much more faster than FPGA platform, which is a push button flow. Again, there are no manual hacks. If you really want to do manual and guided mode, you can get a go up to 10 megahertz also, right? So I think clubbing both Palladium, Protium, they can bring a lot more scalability of your design, performance, and help you to meet your expectation in terms of throughput, what you really need for your verification, right? So I feel that any verification without having proper planning is useless. I need to have proper planning, proper methodology in terms of how you want to execute, how you want to track it, right? So in the industry, we have a technology called vManager, which is traditionally been adopted by many of our customers to track and plan the execution, right? So what is that we added recently new? We have enabled our vManager technology with ML, which is basically help you to localize the bugs. So when you are running a regression, right? So when you can cluster your failures, which will help you to debug much more faster than you doing manually, right? So a lot of ML techniques been added into the vManager that will help you to localize your bug, cluster your bug, so that you can root cause the failure and try to fix the design much more faster. Other thing, as you know, in the industrial and automotive, is very important is the traceability, right? You need to make sure that whatever the test case that you're running, there should be a connection to your functional spec. So traceability is very important, and vManager is enabled with many traceability tools, industry standard tools like Jira, right, Doors, OpenHub, right? So been successfully used by a lot of our automotive customers to present their evidence to auditors so that they can get chip certified, right? So it's proven technology. Again, there are a lot of ML capabilities been enabled. If you want to use it today, you can go ahead and use it. So with that, I can say that having comprehensive verification platform is essential to meet your demand, what you have in the market, right? So we are expecting to grow to $1 trillion by end of 2027. Again, to really want to take the gain of this market growth, you need to have sophisticated chips to come out. There are a lot of companies are doing chip design, right? So, but how do you differentiate your chip with respect to other competition? You need to have better functionality, better features. But features and functionality without verification is no use of it, right? If the chip comes out and fails in the field, there is no value for it, right? So the verification is going to play a very important role in this, making sure that you hit this market and take the advantage of this market. With that, I'll go to end. If you have any questions, I'm going to take the questions. Hope you guys didn't sleep. Or if you have option to ask question to audience, I can ask the questions to check whether they're asleep or awake.
Hi, I'm Maitreyi from Marvel. I have a question. You mentioned about the silicon shortage, right? So, the demand for the silicon or this industry is increasing, and it will further increase in the coming 5 or 10 years. So, how do you think this silicon shortage will affect our industry? I mean, I see as a common man, I see that the devices cost is increasing, but how does it impact our industry?
Yeah. So the good question, right? How the silicon strategy is going to affect us, right? I think definitely is very visible. We are losing people to other companies, right? So people are rotating from one company to other company. There is a lot of demand outside, right? But yeah, keeping fun aside, so definitely more demand for silicon means you really need a lot more empowerment, a lot more employment, right, to meet their expectations, right? So I've seen, when I was talking to one of my friends, when decade back we had hardly 10 to 12 companies who are doing chip designing in India. But now if you take any company in the world, they have headquarters here, right? So a lot of growth in terms of employment, right? But keeping that side, in general, everybody started doing the chip design. It means that there's a lot of competition in the market. As an engineer, you need to be efficient in terms of delivering what your team is expecting or what the company is expecting, right? So it's going to be challenge at the same time opportunity for us to grab it, right? So either you take the 5G, or you take the industrial, automotive, you need to be a little much more innovative in terms of delivering your solutions, right? So whatever you were doing earlier, decade back, same methodology, same techniques may not help you, right? You may need to deliver a chip in less than 6 months. Earlier, you might be taking 2 years to do a chip tape out, but now it's not going to work. You need to be ready by 6 months. How do you squeeze this 2 years to 6 months? You have to do shift left, right? As I mentioned here, start using Helium for high-level virtual analysis. Start adopting more and more formal for IP verification so that you can cut down your verification time that you spend in simulation, emulation. Use dynamic DO so that you can move quickly from emulation to prototyping so that you don't really spend a lot of time in building the design and the prototyping side of it, right? So some of these techniques you really need to adopt. Again, it's a big opportunity for all of us to take this and skill ourselves to address the needs. Hope I answered your question.
Yes, thank you.
Check.
Hi. I'm Arjun from TCS. So I have a quick question. As a verification engineer, we see that there is a lot of news about Python kind of languages being used for verification. We understand the fact that for a silicon tape-out to take place with respect to verification, a lot of cycle-accurate simulations are required, not instruction-accurate, or could be the trade-off of both. But with the advent of Python kind of languages, how do you actually see the future? Will it really become a or kind of steam out SV, UVM kind of a verification is my question.
It's a very interesting question. Again, I didn't touch in my previous slide. If you notice it, there's a Python API been enabled on the View Manager. Means Python is the way I look at it is the next generation verification methodology. I mean, a lot of people going to use Python to verify the designs, right? So either to data mining, data analysis. Now we are trying to give a lot more hooks in our EDA tools, either it's simulation, VAPs, or formal. We're going to give you the Python API for you to build your own scoreboard or build your own checker on top of what we deliver it, right? So definitely Python is the next step. I think in fact, between us, I think I'm training, my A is to be ramped up on Python so that we'll be ready to handle the customer questions down the line, right? So it's going to be another next generation methodology for verification.
You see that it will be creating a traction.
Yes,
It's just a news now, but it will be a traction.
Yes, definitely.
Okay, thank you.
We all need to learn that, yeah.
Thank you. We'll stop with that and move on to the next speaker. First, I'd like to call upon Babu to give a small token of appreciation to Lokesh Babu Pundrika. One minute. Photographer's coming.
Oh, thank you.
Thanks, Lokesh.